I'm Harley Smith, and this is the Master Growers course. And today we're going to be continuing our series on integrated pest management, but we're going to be focusing on the plants, improving the plant's natural resistance to pest and disease. Remember, predators prey on and attack the weak. If you had a pack of wolves, they're not going to go after the bull elk in the herd. They're going to go after the weak, the infirmed, the diseased. It's the same way with plants. If you have just one element out of balance, let's say you're deficient in zinc, it actually affects the potential of the plant, the frequency of the plant, attracts predators to it. So it's very important that we use full spectrum nutrients with nothing out of balance and nothing deficient. We talked about in previous classes about using humic acid and kelp together to improve the plant's resistance to stress. It makes a special molecule called superoxide dismutase that protects the plants against stress, heat stress, salt stress, drought stress, UV stress. But that enzyme has to be activated by a cofactor, either an iron-manganese cofactor or a copper-zinc cofactor. If those trace elements are there in abundance and available to the plant, one molecule of an enzyme could do over 1,000 chemical reactions per second, protect the plants against stress, and increase resistance to pests and disease. So the first step in strengthening the plant's natural resistance to pests and disease is to use full spectrum nutrients with the trace elements. Try to add the trace elements in chelated form. Chela, of course, means claw. So a chelate is an organic molecule that attaches to a mineral like a claw. It holds it tightly enough so it doesn't lock up with other minerals and become unavailable to the plant. But it holds it loosely enough so it's available to the plant on demand. So make sure you're adding chelated trace elements. In hydroponics, it's EDTA, which is a synthetic chelator. It's a strong chelator to help keep iron available, or DTPA, which is another chelator. That's what we use in hydroponics. In soil, it's more important to have plant growth promoting rhizobacteria in the root zone. They make organic acids and enzymes and siderophores that are intermediate chelators that aid with the uptake of the trace elements like copper, like zinc, like iron, and manganese. So, number one, make sure all the elements are there in plant available form. Number two is make sure that the plant can utilize them properly. And the way to do that is watch your pH. So the next step, don't let your pH drift too far. In hydroponics, if the pH gets above 6.5, which is still barely acidic, iron starts to become unavailable to the plant. We can put it in there, the plant can't use it. If it gets above 7.5 pH, which is barely alkaline, all the transition metals, iron, copper, manganese, and zinc we just talked about, that are cofactors for activating enzymes for plant protection, they become unavailable. So make sure you keep your pH in hydroponics between about 5.8 and 6.4. That way, all of the minerals are available to the plant all the time. Now in soil, it's a little different. We can keep the pH of soil a little closer to neutral, somewhere between 6.4, maybe 6.8. That's because the microorganisms prefer pH closer to neutral. But those microorganisms that are living on the roots make organic acids that lower the pH in the root zone and also make the iron and trace metals more available to the plant. So don't let your pH drift too far. Next, do everything in your power to maintain high Brix levels. Now, Brix is a measurement of the sugar content in the sap. If you can grow such healthy plants that the Brix is at 12% or higher, the organic gardeners tell me that sucking insects won't even recognize the plant as food. They won't even land on the plant. And I've done it. I've grown outdoor hydroponics where I would use biostimulants to grow high Brix plants where the Brix was off the scale for premium quality. Not only was it better flavors and aromas and more vitamin content, better color. It was also more insect resistance. I was growing outdoors. I never had one single aphid on my plants. I never had to spray even one time, just because I was improving the uptake of the water and the minerals growing high brix plants. Another step in growing high brix plants is watch your nitrogen to potassium ratio. Nitrogen is a luxury element. The plant will take it in whether it needs it or not, but it takes 20 to 30% of the energy of photosynthesis just to assimilate the nitrates. So if you over-fertilize, you're going to weaken your plants. It'll burn off the bricks, burn off the carbohydrates for top growth. It'll restrict the root growth. Not only does it increase the top growth, though, you'll get big cells with thin cell walls. It'll make it an easier target for sucking insects. It'll make it an easier target for powdery mildew and fungi as well. But if you grow high brix plants, the plants are naturally resistant. So your first step, lower the amount of nitrate nitrogen just to the adequate level, sufficiency. You don't want a deficiency, but you want enough just to keep the plant healthy. You'll get smaller cells, thicker cell walls, more resistance to pests and disease, and you'll have higher brix plants because they won't be burning off 20% of the energy of photosynthesis just to assimilate nutrients they don't even need at that time. The next step, though, is adjust the potassium to nitrogen ratio. If I were going into a commercial greenhouse, say in the UK, as a consultant, the very first thing I would do is I'd do a leaf test. I take the first fully developed leaf from the top of the plant, take some samples, squeeze out a couple of drops of sap onto a brix refractometer. That measures the sugar content in the sap. I can read it like a thermometer. If the brix is too low, the first thing I'll do is adjust my nitrogen to potassium ratio. I'll either lower the nitrogen, or I'll increase the potassium, or I'll do a little bit of both. Because potassium is the health element. It contributes to carbohydrate metabolism for the plant to make more sugars for higher brix, and also to unlock some of the stored sugars so they can flow to the flowers and be stored in the fruit. So if we can increase the brix, we can cut off problems before they even establish themselves. Another way to improve the potassium to nitrate ratio, besides lowering the nitrogen, is add a little bit of potassium. I like to add it in the form of potassium sulfate. The potassium is available to the plant on demand. Now, some of the potassium sulfate products out there are actually certified OMRI as organic, even though they're a mineral supplement. That's because they're mined from the earth with no chemical extraction process and processed into their soluble fins form, very water soluble. If it's water soluble, it's available to the plant. So whether you're an organic gardener or whether you're a hydroponic gardener, you can use special high-quality potassium salts to increase the potassium to nitrogen levels and ratios, increase your brix. Okay, the next step for increasing brix, after you have your nutrients in the right levels, is to add organic biostimulants. One of the best ones to increase brix, amino acids. Amino acids are intermediate chelators, so they help keep the nutrients available, and they also stimulate root cells to open calcium ion channels. The plant takes up more calcium, it's going to be able to use the calcium to make pectin that glues the cell walls together. So if you can improve the calcium uptake by using amino acids, you'll have thicker stems, thicker cell walls, more resistance to pests and disease. I learned that lesson when I was in the Netherlands. Back in the year 2000, they made all fungicides illegal on food crops. So they were losing about 40% of their crop to powdery mildew and gray mold and other fungi. Now in 2001, I was invited to see the research that they were doing, the growers were doing, on organic biostimulants, those that contained amino acids. They went from losing 40% of the crop to losing 0. They got a 10% increase in yield over any past year, and they were first in the line for sugar content in the fruit. High Brix plants. Were growing the best of the best at the greenery, the market in Amsterdam. Here's how it worked. When a mold spore lands on a leaf, such as powdery mildew, it doesn't germinate in the water on the surface of the leaves. You can even wash off the spores if you want to. No problem. Growers often do. But what happens is the powdery mildew spore sends down a germination tube to penetrate the leaves to get to the water in the interstitial space. Then it germinates, becomes systemic in the tissue, and then it starts to make spores and spread. But if you add biostimulants that contain amino acids instead of water in the interstitial space, you have pectin, calcium pectate, thicker cell walls too. So by the time the mold spore is able to get to the water in the interstitial space, it dries up and dies. So you're not killing the powdery mildew. It's not a poison. It's preventing the powdery mildew from getting established and then spreading. So we're improving the plant's natural resistance to pests and disease by using biostimulants with amino acids in them. By the way, that'll contribute to Brix as well. We want to grow high Brix plants, right? If you add the amino acids, plants take up the calcium, it strengthens the vascular system of the plant. So the plant can take up water and all of the other minerals more efficiently, including trace elements like iron and copper and manganese and zinc. That adds another level of plant protection to the plant. So we're working with nature in a positive way to get beneficial side effects. And nature is doing this. It's been doing it without our help for millions of years. Microorganisms in the root zone make a protease and digestive enzymes that change proteins into amino acids right on the surface of the roots. Some of those amino acids aid with the uptake of calcium. That's why many organic gardeners out there, where they have an enthusiastic community of microorganisms in the root zone, tell me time and time again that their plants are naturally resistant to pest and disease. But if you're doing chemical farming and overdoing it with nitrogen, you're weakening the plants, so you have to spray more pesticides. It's a very negative spiral, downward spiral, when you do it that way. So let's grow high Brix plants to improve the plant's natural resistance to pest and disease while we're improving quality and improving the yield. There are other biostimulants you can use as well to improve Brix, and we talk about them a lot in our other classes. I have a whole class just on biostimulants. But to improve the plant's resistance to pest and disease, there's a couple more key ones. Well, amino acids are first. That's key to get the calcium uptake. But also you could use humic and fulvic acid as a foliar spray and at the root. Humic and fulvic acids, like amino acids, are intermediate chelators, but they have an effect on the uptake of the trace elements. Again, like iron, copper, manganese, and zinc. If you have a dose of humic and fulvic acids at the roots, it stimulates the plant to make an enzyme that pumps protons, a proton pump. It's called H plus ATPase for you science guys out there. It pumps protons, so the outside of the cell membrane becomes more positively charged. The inside becomes more negatively charged. The voltage potential across the membrane increases. That's energy the plant can use to take up some of the transition metals, iron, copper, manganese, zinc, and others. Even other nutrients, even the nitrate nitrogen, will become more efficiently utilized by the plants. The plants take up the nitrogen, they make amino acids, they make enzymes, they do the chemistry of life, they make chlorophyll, so we stimulate the entire process for growing high Brix plants. If you use the fulvic acid, though, as a foliar, that adds the trace elements directly. Humic and fulvic acids have over 62 beneficial trace elements that are harvested from ancient compost piles. Back when the earth was young and vegetation was huge upon the planet, well, those ancient compost piles still have some of those trace elements, those small organic molecules that are biologically active. If you use fulvic acid as a foliar spray, it'll transport the iron through the cell membranes, release it inside the cell where it's needed the most. And as that happens, the plant uses the iron to make more chlorophyll, the chlorophyll to harvest more light energy, and photosynthesis from the light to make more sugars. The results? Higher Brix. We increase the Brix of our plants. There's more stored energy to fight off pests and disease, and more stored energy to make an abundant harvest of fruit and flowers. Some of the biostimulant products are very, very good at helping the plant increase the Brix. Would be kelp extracts, number one, humic and fulvic acids. They work synergistically with the kelp to help with more lateral root growth, more root mass. The plant develops more roots early on. It can take up more minerals. Takes up more minerals, it'll have more resistance to pests and disease. Another biostimulant to help with Brix, B vitamins. It doesn't have a direct effect on the metabolism of the plant, but it stimulates the resistance to pests and disease, especially the root pathogens. What it does is a high dose of B1 thiamine, when used at the roots as a root drench, stimulates the plant's systemic induced resistance. In other words, it primes the plant, sensitizes the plant, and puts it on high alert. So if the plant is under attack, say by a root rot pathogen, a fungal pathogen, the plant's natural immune system responds very quickly. Now that's a problem. If you have roots that are dying back, they're not going to be able to take up iron. They're not going to be able to take up calcium. You'll see symptoms of nutrient deficiencies, and then the pests are going to attack it. Remember, the pests attack the weak. So we need to have healthy growing roots. We want to stimulate root development from seed all the way to harvest. So kelp, humic and fulvic acids, B vitamins are all going to have a positive effect on the Brix of the plant. Next, let's look at some of the environmental factors that will improve the plant's natural resistance to pests and disease. First of all, make sure you maintain your relative humidity in a good zone for plants, somewhere between about 40% to 60%. If your humidity is too high, then the plants won't transpire as much water. The air is too wet. You can get a calcium deficiency, even if you have plenty of calcium at the root zone. So we want to make sure we have good relative humidity to keep the nutrients flowing to every cell for increasing the plant's resistance to pests and disease and fungi. Also, make sure there's adequate air movement. When plants are doing photosynthesis, they take in carbon dioxide from the air, but they transpire oxygen and transpire water vapor. If you don't have good air movement, so the leaves are moving at least a little bit, then the plants can develop a vapor barrier on the bottom of the leaves. When that happens, instead of assimilating carbon dioxide, they produce carbon dioxide. It reduces the Brix. So very important to have enough gentle air movement so all the leaves in the garden are moving at least a little bit to blow away in a gentle breeze the waste water vapor from transpiration and photosynthesis. Next, we want to avoid temperature extremes. Yes, we can use humic acid and kelp in a 5-to-2 ratio to help the plants produce more enzymes to protect them against stress. But that doesn't mean you produce a stressful environment. Keep the temperatures in the adequate zone, somewhere between 68 degrees and 78 degrees. Also watch temperature extremes between day and night. The bigger the temperature difference between day and night, the more the plant tends to stretch. It'll burn up more of the carbohydrates into stretching. You want to try to have that nice, tight internodal length, that nice 2-inch internodal length all the way up the plant with thicker stems to promote the energy of the plant and direct it into fruit and flower production and into stress tolerance. And finally, maintain the root temperature between about 68 degrees and 75 degrees Fahrenheit. If the water gets too warm in the root zone, the warmer the water, the less dissolved oxygen it'll hold. Now, the anaerobic fungi, the pythium, the rhizoctonia, the root rots, grow in stagnant water without oxygen. Even a little oxygen will kill the pathogenic fungi. One of the emergency treatments you can use if you have a little bit of root rot, because that can affect the whole disease resistance of the plant. One of the emergency treatments, add a little hydrogen peroxide to your water. Hydrogen peroxide breaks down into oxygen and into water. You put a dose at the roots, it'll kill the root pathogens on contact.